everyone, this is Mr. Cervone. Welcome to my math channel. In today's logic lesson, we will be learning about logic proofs. So for the do now, it says, show the steps and explain why we can conclude that the last statement is true below. As you can see here, we have statements such as P or Q, if R then T, if Q then not T, R, therefore P is true. So what can we say here? Well, what can we say is that these here, let me use a pen here, there you go. These are our premises, okay? And what can we say about the premises or our givens? That they must be true, okay? So these are always assumed to be true, the premises. So we want to actually prove this, okay? So let me write this down, prove this. Okay, now how do we do that? The way we do it is to use all the laws of inferences that we have learned so far. As you remember, we learned 10 laws of inferences. In the previous video, we summarized all the laws of inferences. For example, the law of detachment or modus ponens. Then we have the law of contrapositive, the law of modus tollens. Then we have a chain rule here, or we can call it the law of syllogism. Then we have a law of disjunctive inference. Then for number 6, we have the law of double negation, the De Morgan's law of simplification, law of conjunction, and the law of disjunctive addition. So if we go back now to our do now, we want to somehow use any of these 10 laws of inferences to prove that P must be true. So at this point, I encourage you to pause the video, write down the do now, and see if you can use the laws of inferences to prove it, okay? Okay, so at this point, there are many ways to prove the same exact thing. So what I always recommend is to somehow use the givens that you can somehow combine them. Let's say you take the second given over here, okay? If R then T, and then we're going to take R. Is there a way to combine it? And the answer is yes, okay? So let me write this out. So we have if R, then T, then we have R. Now, is there anything we can conclude from these two givens? So the answer is yes. If R then T is true, if R true, therefore T must be true. And what's the law that justifies this step? As you remember, this is called the modus ponens, or the law of detachment. So I'm going to call this step 1. Okay, now we know that T is true. And I'm going to erase this. And let's think about this now. We already used the second given and we used the fourth given. So we cannot really use it again. Now, can we use the T in conjunction with any other givens here? So we only have 2 givens left. We have this given and we have the third given. Well, we cannot really use the first given in conjunction with T because there's no T variable in the first given. We are only going to use the third given, this one. So let's write this out. As a second step, we're going to write if Q, then not T. Now, from this step here, so let me use a different color here. So we know that this T over here, we can place it here, okay? And just write it out as T. Okay, so we know that if Q then not T is true, we know that T is true. Therefore, what must be true? Not Q must be true. And again, this is called modus tollens. Okay? So we basically now use the third given. And we're only left with the first given. And we know that not Q is true. Okay? So what we can do now as a third step, we can write P or Q And again, let me use a different color. We know that not Q is true, and that we're going to use for our third step. So let's change color again, and here we have not Q. And what do we remember from this here? It's P or Q, but it's not Q, therefore it must be P, okay? So that is called the law of disjunctive inference. Okay, and we're basically done with our proof, okay? Remember, our goal is that we had to prove this part over here. We had to prove that P was true. And we actually did prove it, okay? So we did answer the do now. So what we just did is a logic proof, okay? And proofs are going to accompany us for the rest of the geometry course here. And as a matter of fact, let me first define what a proof is. A proof is a convincing argument that a statement is true, okay? Now, I hope I all convinced you here that P must be true given all these premises. So we're all convinced now. Now, it turns out that for the most part, proofs are not done this way, but are done using something called a statement reason table. So let me introduce what that is. So a statement reason table is basically a table where you can organize all your steps that we just did. So let me draw a table here like this. And on the left side, I'm going to call it statements. And here, I'm going to call that reasons. Okay, so what we want to do here is in the table is to add all our steps that we performed here, okay, to prove the P is true. How do we do that? Well, we just follow the steps here, okay? So number one, first we write if R then T, and then we write R, and then as a third step, you're gonna write T, okay? So let's do that. So here, for number one, we're gonna write if R then T. Then as a second step, as you remember, we wrote R, and then we prove that T is true. So what are the steps or what are the reasons here? So for number one, the reason is just given, okay? So that was a given premise, and we assumed it to be true. The second step is also given, and then T, why did we conclude that T was true? Well, when you go back here, we know that the reason is modus ponens, okay? So let's write that in here as a reason for number three, modus ponens. Okay, now we want to also put citations, and that is very important, okay? So we're going to put citation 1, 2, because what that means is that we're referring to step 1 and 2 to conclude modus ponens that T is true, okay? Okay, so let's continue now. For step number 4, now if you go back up here, we actually use the T. So it turns out that in the statement reason table, we do not need to rewrite T. So let's first write the second given, which is if Q then not T. So here we're going to write if Q then not T. Okay, so that is our given. And, you know, at this point, do we need to rewrite T here? The answer is no, because we actually already have it in step 3. And that's the reason why we want to use citations, so we don't need to rewrite things again. Okay, so for number 5, so here we concluded that not Q is true, okay? And here we're gonna write modus tollens. And the reason is 3, 4, modus tollens, okay? That's the citation. Okay, now for number 6, let's go back again. here we have P or Q, and then we're going to use not Q to conclude P is true. So here we're going to write P or Q. And step number 6, that's given. And then for step number 7, now we know not Q is true, P and Q is true, therefore P has to be true, okay? And again, this is called the law of disjunctive inference. Let me actually write the E a little better. Okay, so now we used steps 5 and 6, okay? Okay, ladies and gentlemen, we're actually done, okay? So what we just did is something called a formal proof. So let me write this here on the side. So what we just did is a formal proof. Okay, so that's what we did. And you know what we did here, this is called an informal proof. So the way you can think of this is the following. On an exam or on a homework assignment, you're really not required to do an informal proof, but it's actually kind of like a brainstorm. You can do a formal proof if you would like to, but you don't have to, okay? The most important thing is that you do have a formal proof, a statement reason table, and that is actually how the format will also look like on the Regents exam, okay? So I highly encourage you to really know how to do statement reason tables, okay? Okay, so let's look at another example now. Let's say you have the following 3 premises. If apples are red, then bananas are vegetables. If apples are not red, then candy is delicious. Bananas are not vegetables. Can you prove that candy is delicious? Well, how do we solve this, or how do we prove that candy is delicious? Well, what we can do here is first assign letters to each of the statements. So here are the letters that we assign for each statement. Let A be apples are red. Let B be the statement bananas are vegetables. And let C be the statement candies are delicious. Obviously, you can use any other letters if you would like, but in this case, I think that A, B, and C are the most convenient letters to use here according to the statements. So what is the second step? Well, the second step is to rewrite the 3 premises and what we want to prove in terms of these letters. So here we rewrote now everything in terms of the letters. If apples are red, then the bananas are vegetables correspond to if A then B. If apples are not red, then candy is delicious. So we write if not A then C. Then bananas are not vegetables, that is not B. Therefore candy is delicious, therefore C. Okay? Now we can go ahead and actually prove it. So for step 3, let's first do the informal proof, okay? Let's do basically our brainstorm and then we do the formal proof later. So now again, as we did in the do now, we want to somehow combine the givens and somehow conclude something, okay? And we can already do a few things here, okay? And there are different ways to do it. For example, what we can do here, let's say we take the first given, if A then B, and then we write not B, okay? So now we can conclude that not A is true. So let me write therefore not A is true. And what's the law here? So we can call it modus tollens. Okay, so that's step 1. So for step number 2, now we use the first given. We know that not A is true. Now we can use the second given. If not A, then C. So we're going to use the not A from the previous step that we just proved. Therefore, what can we say here? That C is true. And here we used modus ponens, okay? And by the way, here we actually used also the third given in the first step, and the second given in the second step. So if you think about it, this is actually a two-step proof. It's actually very, very simple. There's also an alternative way to do this. So let me write this here. An alternative way to prove it is the following. Let's say you have if A then B first. So what we can do with the second given, if not A then C, we can actually conclude that if not C then A must be true. Okay? So as you remember, this is called the law of contrapositive. Okay? So let me put a line here. And now what we can do is use the first given. So we have if A, then B. And we can use it with this given here, or whatever we just proved. If not C, then A. Now, as you remember, we can now apply the chain rule. Okay? So let me write this here. If not C, then A, and if A, then B. Therefore, if not C, then B must be true. And then we still have not B left. Okay? And if not C, then B, but it's not B, therefore it has to be C, okay? And that is actually called a modus tollens. So that's an alternative way to do it, okay? But let's stick with the one that only has two steps, because what I'm trying to tell you here is that when you do a homework assignment or when you have an assessment, sometimes you want to brainstorm to see which proof yields the least amount of steps so you can actually finish your assessment in a certain given time. Okay, so now let's go to step number 4, which is now the formal proof. And again, in a formal proof, we want to set up a statement reason table. Okay, so let me get the marker here. There you go. Okay, so we're going to write statement reason here. All right, so for number 1, and we look at the steps. First, we wrote if A, then B. Okay, so that was a given. The second step, as you can see here, we had not B. So that's also a given. And then as a third step, we concluded that not A must be true. Okay, so that is called modus tollens. And again, please let's not forget about the citations. We have 1, 2 because we're using step 1 and 2 to conclude 3 is true. Okay, then for step number 4, we look at our second step in the informal proof. We wrote if not A, then C. If not A, then C, which is given. And now we don't need to rewrite not A, right? Because we already have it in step 3. So as step 5, if you combine step 3 and 4, if not A then C, it's not A, therefore C has to be true. So that is now modus ponens for steps 3 and 4, okay? Okay, and that's basically it. We're done with our formal proof, and we proved that candy is delicious, okay? Okay, so here's one final practice problem for you guys. So I'm not going to go over this problem. I'm just going to show you the problem first, and then I'll show you the answer. So what I want you to do is to please look at this, pause the video. Okay, look at the given, if P then not Q, if R then T, if not Q then not T, P or Z, R, those are all the given premises which are true. How do you prove Z is true? So go ahead and pause the video now, try it out, and then I'll give you the answer, okay? Okay, so at this point, let me show you the answer. Okay, so here's the answer, the statement reason table. So what I did here is first write if R then T as the given, and also pick the last given, the R. As you can see, you can actually conclude T is true in the third step because of the modus ponens. So I use step 1 and 2 for those. Then I wrote the given if not Q then not T, which then allows me to conclude that Q is true in step 5 because of modus tollens. And then in step 6, I added the next given, which is if P then not Q, which then allows me to conclude that not P is true because of modus tollens. Then I'll add the last given for step 8, P or Z, but it's not P in step 7, therefore Z must be true because of the law of disjunctive inference. Now keep in mind that a lot of time these types of proofs have different ways to prove it, okay? So that's one way I proved it, but again, you could have probably done it in different ways. For example, maybe you can combine the first and the third given, right? If P then not Q, if not Q then not T, and then by the chain rule can say if P then not T, right? Then you can use the law of contrapositive of the second given, if not T then not R, and combine that again with the previous given that I just mentioned. And then you can use the R with that, and so on and so on. But yeah, there are different ways to prove these, okay? So my recommendation is to always use the proof that you feel most comfortable with, okay? And then as time goes on and you become more and more proficient with these types of proofs, you can actually tweak it around and use the one that yields the least amount of steps, okay? But that's basically it for today. I hope you enjoyed this video. If you have any questions, please post a comment on the YouTube video or email me. Otherwise, please click subscribe button, click the like button if you enjoyed the video, and otherwise, have a fantastic day.